So, my name is Chris Tankersley. Hopefully you remember me from yesterday. But today I'm going to talk actually about Docker and some things that we can do and think about as we start to design workflows and move it more into the development stage. Docker is one of those things that has really started to pick up over the last 3-4 years as a development tool as opposed to just primarily a deployment system. Even though originally that's kind of how it was designed. So I stole this from the Docker website years ago. I don't even know if this page exists anymore. But Docker's billed as an open platform for developers and sysadmins to build, ship, and run distributed applications. And that was primarily its core focus. It wasn't necessarily designed as a development tool, but we make it work for us because realistically we want our setups to work all the way from development to production. And we want to get away from that it works on my machine mentality. So depending on how long you've been doing development, we went through the same kind of renaissance 7-8 years ago with tools like Vagrant, which made virtualization a much more attractive option for doing development because it fixed a lot of problems. Doing work directly on your machine causes inconsistencies that you don't want to have, minor PHP version differences, configuration differences. And Vagrant promised kind of that same setup to get rid of the it works on my machine problem, but very few places actually followed through on it, as they generally didn't use the same Puppet or Ansible configs in Vagrant that they actually used in production, if they used any at all. Docker still kind of has that problem, but one of the big advantages is you have a same binary base across the board, so it even lessens that more and more. It's kind of at the bottom of here. Docker enables apps to be quickly assembled from components and eliminates the friction between development, QA, and production environments. And that's really the big thing that we worry about as developers, is making sure that our workflows from dev to production are as seamless as possible and we can reuse those environments as much as possible. So I'm going to spend just a small portion of time on exactly what a container is. If you are not familiar with how Docker works already, I would suggest maybe going to one of the other talks. I'm not really going to go over the basic fundamentals of Docker above and beyond this because how a container works is a very important topic. So if you're not sure how Docker works or exactly how you want to get like Compose set up, this is going to be a little bit slightly higher level. But I want to make sure that we're all on the same page on what a container is, because what containers are kind of influences how we actually structure our workflows. So in the really old days of my previous job last year, you would deploy code to a bare metal server. And in all honesty, 80% of the projects I work on probably still get deployed to a bare metal server. It's really easy to set up. It's very non-resource intensive, but from like a large enterprise setup, or like you look at someone like DigitalOcean or AWS or Rackspace, it's super inefficient. So we've got a fake little computer here with some processes being used. In a normal setup, you've got your processes up there in green. They talk to an operating system, and the operating system talks to the hardware. And this works really well. If your PHP application says, I want RAM, it asks the operating system instead of having to understand how to talk to the actual physical hardware to get that RAM. Now, there is a little bit of overhead. Our operating system takes up some resources, so that's our graph on the side. We're going to say our operating system takes up 10%, CPU, 20% RAM. And then our application sits on top of that and gobbles up some more of that. Makes total sense. We use resources. But if we have a single application on a single server, that's really inefficient. But we really don't want to overload servers too much, and there are issues, especially security issues, with shared hosts. So a lot of places moved over to virtual machines, and this worked great. This is why Vagrant was so powerful, but there's a lot more resources used with all of this. So generally with a virtual machine, we still have our base operating system. We have the hardware at the bottom, but then we have this intermediary layer called a hypervisor. Sometimes that's built into the operating system. Sometimes it's a completely separate software product like VirtualBox. You have things like Hyper-V in Windows, which kind of blur that line. But basically, the hypervisor is an intermediary between the virtualized operating system and the real one. So whenever you deploy an application, you get a whole new operating system with all of the processes on top of it. So our resource usage goes up, but we get the better separation of concerns between those individual machines. That's great for big companies like AWS and Rackspace and stuff, because they can shove more operating systems on a single machine, not worry about them clobbering each other with different configuration needs or whatever, and you get some benefits of being able to like move them around through like some of the various VMware technologies. You can do cool things like hot swap VMs with no downtime. But there's a lot of overhead with that, because if your PHP application needs to read a file, PHP talks to the virtualized operating system, which then has to talk to the hypervisor, which then has to talk to the real operating system, which then has to ask the hard drive for the information, and then it has to flow all back up. How many people in here use Mac OS with Docker? That's why it's so slow. Because we cheat, and I'll talk a little bit more about that in a bit. So, but what containers do is let you run everything bare metal, but just separates out the processes themselves into little walled gardens. So here we've got them walled off in the red. With our VMs, it comes up kind of brownish on here, but our VMs are separated by the red boundary here. Containers, we do the same thing, but you'll notice there's no intermediary layer. So if PHP asks for RAM, it's going to ask the actual operating system, and the operating system will give it RAM. The separation just becomes what the processes can actually see alongside themselves. So they're literally just walled processes. So in a normal setup, you have a kernel sitting at the top. 90% of the time it's going to be some sort of Linux kernel. So we're going to fake it and say it's the Ubuntu kernel here. And that has its own worldview. So everything that's in the root directory, you got your bin, your etc, your var ww clients, whatever. And when you run processes, they talk directly to the kernel, and the kernel, by default, looks at that view. All a container does is create a new view and point a process to that new view. That new view gives us some things like not being able to see other people's processes, getting your own separate network topology, all kinds of nice little things. But at a high level, all it's doing is just creating another little world inside your system. So Docker itself, when you get right down to it, is just Vagrant for containers. Docker doesn't actually do anything magical. It's using existing technologies. Docker nowadays, especially, is an entire ecosystem. So we get this kind of muddled terminology with, like, when we say Docker, what exactly are we talking about? 9 times out of 10, you're probably talking about Docker Engine, which is the actual thing that, the command line you're typing into and the API that it's talking to. You have a couple other things on top of that, like Machine, Compose, and Swarm, though I really should probably take Swarm out at this point because nobody uses it. It failed in the market. But you've got Docker Compose for your orchestration and Docker Machine for building machines that do Docker. So where a lot of the pain points come in, especially as you start to talk about Docker with teams, is how it actually works for you individually on your machines. So if you're like me, and despite having a MacBook, I generally actually do most of my programming on Linux. So it works out of the box using a bunch of built-in things into the Linux kernel, because Docker is primarily actually a Linux technology. It takes advantage of things like C groups and the way it handles processes and visibility straight out of the box. It can use a variety of different container technologies under the hood, but primarily it's just talking to a Linux kernel. Because it talks to a Linux kernel, the other two options, Windows and Mac OS, all actually have a virtual machine in there, which eats up some resources and causes some additional pain points because you're probably not deploying to a Docker install on Windows or a Docker install on OS X. I'll put a little asterisk next to that. So with OS X, most of your problems you're going to run into are because of that virtualization layer. It doesn't quite handle port binding the way that it does in Linux or it will in production, ignoring that you're probably running like Kubernetes and stuff in production. But just straight Docker, It works a little bit differently because you can do different port bindings, and Docker expects ports to work a specific way, and they kind of fudge a lot of that in OS X. Because of the X-Hive virtualization layer, that layer actually has a really poor I/O implementation. So if you're using Laravel, basically anything kind of Symfony-based that uses a lot of annotations reading and a lot of I/O, their I/O layer at the operating system level is super inefficient, which is what causes all of the slowdowns. It's not actually a Docker problem, and it's also a problem you'll never have in production. It exists solely because of that virtualization layer. Windows actually has 3 different ways to run containers, all fully supported by Microsoft and Docker. The bottom 2 are the most common use cases for people. So you have Hyper-V containers where there is a virtual machine running. Like OS X, it sets up a small little Linux machine, actually running a distribution called Moby Linux, and runs everything in there. The newer style way, which is still technically in beta preview, is the WSL2 stuff. Do we have anybody in here who runs Windows? Okay, decent handful. WSL2 and everything is wonderful. I love it. It works with native containers, but still actually in a virtual machine, because WSL2 has moved to a virtual machine. WSL1 doesn't use a virtual machine. It actually has this weird translation layer to turn POSIX stuff into native Windows calls, which is why there was no overhead with WSL1. WSL2 introduces a tiny amount of overhead, but they've done a ton of work to get that to work. It's not actually a full-on Linux installation, though. So if you need things that use like systemd, it doesn't work. But Docker is working with Microsoft to actually make that all work itself. Windows is in a unique position as well because they actually have a native server technology that they kind of worked with Docker to do. You can actually Dockerize Windows programs, Windows core apps. So .NET can actually be distributed as a Windows container, or what they call a server container. And you can deploy that on server 2016 and up, and I believe Windows Pro and up through Docker Desktop. So if you're building Windows applications or .NET applications, you can actually compile them as a Windows binary and ship them off as a container. There's no VM involved because a Windows binary knows how to talk to a Windows kernel. There's no need for an intermediary layer. We have to use virtual machines because we tend to run Linux binaries on non-Linux systems. So you can't expect a Linux binary to understand how to talk to a Windows NT kernel or the mock kernel inside OS X. So that's why we have those virtualization layers, and they will probably never go away. Apple doesn't seem to be interested in coming up with their own kernel setup, but even if they did, you'd have to get Mac OS containers, which would be separate from your Linux containers, which are separate from what you probably deploy into production. There is the kind of like Linuxy, the Pi subset of containers, because those are ARM processors, not generally x86 processors. You have to get Pi-specific containers for a lot of those things. If you are on an old version of OS X, or you're on Windows less than 10, or you're not on Windows Pro, sorry, pay the upgrade fee to Windows Professional. There is Docker Toolbox. I do not suggest using it at all. Many of you are laughing, but it's using VirtualBox, which has its own performance problems, especially with the file mounting system. So if you think it's bad on OS X natively, it gets worse with Docker Toolbox. So they offer it, but it is definitely a best effort kind of thing. You will have much less headaches just upgrading your operating system level as much as you can, or paying the license fee to go from home to pro. If you are in an environment where your company says no, I don't know really how to help you. Install a Linux virtual machine. But I really caution you to not standardize on Docker Toolbox. I've been giving this talk in various forms for many, many years, and we have finally gotten to the point where I think it's very comfortable to say we don't use Docker for everything anymore. It really is turning into a development layer tool. containers are not just Docker. In fact, in production, you're probably not actually running Docker. How many people in here are running Kubernetes? A good smattering of you. It's probably not using the Docker engine under the hood. It actually uses a different container technology under there. The cool thing is all of these different tools are talking to each other, so you can use all of those things back and forth, and you can reduce that friction even if you're not using the tooling from top to bottom. Red Hat's been working a lot on their Podman tool, which is a rootless version of running containers. It can run Docker containers, and it has its own, it uses the standard, there's a standard for how you should build images and things like that, and it'll use those as well. Once they get all of the Docker Compose translation stuff handled, I'm going to probably assume that's what a lot of people are going to start running in production for simpler applications. Kubernetes has won the distributed, like, multi-node system. So I'm not going to get into like production level stuff here because that's a whole other ball of wax. But just remember that Docker is a single portion of the ecosystem, not the entire ecosystem. So probably one of the best ways to think about the workflows for what you want to do is this idea of a 12-factor application. I believe it's 12factor.net has a list of really good ideas to think about as you're building distributed applications. And even if ultimately you're not going to have an application that needs to scale to hundreds of containers, because Docker was designed with distributed in mind, 12-factor applications give us a lot of things to think about and implement as we start to add workflows to our things. Because there are a lot of anti-patterns in Docker that you can really fall into because they're easy, but that will make production deployment very hard. And if you follow many of these workflows, you're actually going to get to a point where pushing to production should be fairly seamlessly, even if currently you're deploying to a bare metal server and you're just using Docker for development. So a couple of these are going to sound really, really obvious. Is anybody in here not using some sort of version control? Even if you're still using CVS, is anybody not using version control? This is the first conference in a while where at least not one person has risen their hand. You want to keep everything in version control for many obvious reasons, but the big reason for that is you need to start keeping track of everything in time. You should have a single repository for every full application that you're deploying. I don't care if it's a microservice or a monolith or whatever. Everything for an application goes into a singular repository. I've worked on some consulting contracts where you have your config stored in a specific directory, your application in another. For example, they're building an application currently in Vagrant, so that has its own config repository, and the Docker stuff's in another one, and you marry those two things together when you do a deploy. That stuff gets out of sync. Anything that you need for your application goes into the repository, sans like private configuration thingies. If you're not tagging your releases now, begin to tag them. For many of us, this is probably a kind of a duh thing, but there's many places that don't tag any of their releases. You want to start getting in the habit of being able to say, I released this thing on this day. Pick semver, pick date-based, pick incremental, I don't care, but pick something consistent that you can point back to and say that I deployed version 5.3 on this day. I can go back to 5.3 and look at it as of that snapshot. Has anybody ever moved a tag? You are better than some Fortune 500 companies I've worked with. You can move tags, you can delete them and retag things. Don't ever do that because then you lose confidence in what a version number is. One company I consulted for, at one point we had 5 different versions of, what was it? It was 2.3 of an application. Deployed to customers. You could not guarantee 2.3 was the same from customer to customer. Doing tech support for that was a nightmare for that team because they literally had to figure out which git commit would that 2.3 pointed to. So don't ever move a tag. If you tag something and you find a bug, congratulations, you have a new tag. You don't move the other one. I don't care if you found it 4 hours after, you make a new release and run your unit tests. If you're not running unit tests, run unit tests. I love this debate, monoliths versus microservices. Is anybody considering moving to microservices? Ask yourself really heavily why you're moving to a microservice. There is nothing wrong with a properly constructed monolith. If you cannot construct a monolith now, you cannot construct a microservice. If you're breaking up a monolith, congratulations, your monolith now exists on 5 different servers. Microservices have their place, but you really need to treat them as separate applications, not as one big global application. Each part of your microservice needs to be treated as some sort of third-party service. I have no control over Twitter, so if my application relies on Twitter, I have to be completely separate from them. Twitter's not going to say, oh, hey, by the way, we're going to break this in 6 months, make sure that you're up to date, and that you deploy on March 25th, because we're also going to deploy. If you have to have that level of granularity with your deploys, you just have a monolith that you've broken up and now just have to figure out all that coding stuff. Microservices are not bad, but you have to treat them as separate applications. If you store all of your microservices in, let's say, a gigantic mono repo, congratulations, you have a monolith. Treat any microservice you have as a separate project completely. They can all be handled by the same team, but they have to be thought of as complete, concrete, separate applications in their own repository, with their own deploy steps, with their own configuration. Kind of like with the bare metal stuff, I generally just build monolithic applications because they work. They can scale just as well. So if you're going to move to microservices, especially if you're breaking up a monolith, ask yourself what you're gaining out of it before you make that step. It might look like it will help you with Docker, but it probably won't. This is another dull one for us as PHP developers, but you should declare all of your dependencies. Don't do something like commit your vendor directory to your repository. It's bad. It gets you in the habit of editing those files with no kind of way to actually audit those if you need to update. But you need to explicitly declare and isolate those dependencies, regardless if it's a package.json, a composer.json, whatever else you're using for your application. Hot take of the day, commit composer.json and your composer lock files, both of them. The only time you don't do that is when you're distributing a library, but at that point, you're not building containers, so it doesn't really matter. So like my day job, I work on the PHP SDK at Nexmo. We don't ship a lock file because that introduces some compatibility issues with people trying to build their stuff sometimes. Guzzle is a great collider with our stuff if we ship a composer.lock file. So we just ship a composer.json. If you're shipping an entire application, commit your lock file. That way you get the specific version that you know works with all of your tests and all of that. It also helps if you need to rebuild an older version so that you make sure you get the old version of the libraries you're using and you can debug those properly. One company I worked with, we didn't commit the lock file, so if we had to go back to an old version for a customer because they just hadn't upgraded, I got newer versions of libraries which may introduce slight bugs. Despite how well people follow Semver, sometimes those things slip through, and maybe they were being caused by a library bug that has since been fixed in a patch update, but we would never know because we didn't keep a lock file. And kind of along that, when you're talking with Docker, also commit all your Docker files to that same repository that you keep everything else in. Your Docker file is a dependency. It tells you what image you're going to be building from and the steps you need to build it. So that needs to live alongside the rest of your code base. For configuration, you're going to have to look at how you're going to split that up. But ultimately, you want to start storing your configuration files in the environment itself, not as files or .m files or whatever. You want to make sure that your application can just request whatever it needs from the system, and it will make life much easier to deploy. Anything that's environment specific should move to these configuration variables. If you want to ship like a default, like set pagination automatically to 25, or a default time zone for a new customer deploy or whatever. That's not quite so bad. But things like, where's my database located? Where's my caching located? Where are my PHP servers at? Those things should start to move to environment variables. We sometimes get in the habit of being stuck on like, oh, well, I shipped a .m file, so we're kind of doing it. But if you're shipping a file, you're still kind of doing it wrong. .m exists so that we can replicate environment variables in development, not as a way to actually deploy them. This makes it a lot easier to deploy your code because you can pull an image down, give it some config environment variables, and start it up. You don't have to edit any files. You can just point it to your dev database or whatever and move those things around. It's a lot less you have to maintain in the containers themselves. As you go through and you think about, okay, when do I need this configuration? How do I pull it out? And you just start to say, well, I need configuration, just start using getenv. Your code cares less about what external services it's talking to, and it makes you think about where you're actually hard coding things in. For Docker itself, depending on how you're actually invoking your application, if you're just doing like a real basic app, prototyping something, you can use the -e command or the -e parameter and do multiples of them to do var name equals value, and that will pass them in as a normal environment variable. If you have a lot of them that you use commonly, you can use --env -file and pass it in any file that has all of these things skeletoned out as well. And you can use them in parallel. So if you want to change something real quick, you can throw a -e in there and kind of override stuff. If you're using Docker Compose, you can also specify this. So there is an environment file and an env section in Docker Compose if you want to hard code that kind of stuff. But get in the habit of pulling those things out and tracking them that way instead of worrying about what goes into a configuration file. And speaking of that, anything that is not your application, treat as a third party. Treat as something that you don't actually have any control over. So one big thing that we do, like when we talk to database server, usually like MySQL, we just say, connect to MySQL on localhost. Well, with Docker, you don't have a concept of a local socket. Technically they're there, but you can't talk to MySQL because MySQL is not running in your container. You need to get in the habit of talking to everything over a network, but then also thinking about, well, if it's over a network, it's technically external. How do I handle failures? How do I handle network latency? I know most of the projects I work on, we will probably use RDS in production, but not development. So being able to separate those things out through things like the configuration files, but then still treating it as a network resource, really come in handy. There's less I have to do in my application code if I just assume it's a network request across the board. You don't really have to start thinking about anything that's running locally on the box. Like what do I need to have on the machine for my application to run? Your application just needs whatever it has. Everything else is external. You can do things like scale up your database server through proper database scaling techniques, because don't run your database in Docker. That's not how they scale. But you can take care of things specifically, and then if you need to swap out to a third-party service like a SaaS or whatever, you can run fake versions of them locally and then point to the real ones in the real-world environment. If you're using environment variables, it should just be an environment variable config change, no code changes. And it makes it a lot easier to scale up, especially as you start to scale up individual containers in the back end, which is another thing we'll consider. But you can, if you start to treat everything as external, you can scale your individual pieces of your application much easier. There's nothing specifically inherent in Docker to do this. This is something that's probably going to be a code change for you, but it is something to consider as you're starting to architect your application and build the workflow for yourself. Your build, release, and run steps should be separate concrete stages that individually can be run by themselves and rerun by themselves with the same output. So you should end up with actually 3 steps every time you do a deploy. The first one is your build step. That's going to take all of your dependencies, compiles any files you have. Like if you're, for the most part for us, it's going to be pulling down Composer and probably running npm install But if you're using like Python, if it's got to compile any files in the back end, do that. And you'll get some sort of artifact out of that. Depending on what you're using, that might be a tar file. For Docker, it's probably going to be an image file. But this will be a thing that has no configuration or deployment information in it whatsoever. This is just a thing that I can put on another machine with some configuration and have it work. Your release step will pull a build artifact off the shelf and then start to prep that and put that into production. And then your run step will actually do the flipping from one version to the next. So for Docker itself, you want to start thinking about this build step as being an image that comes with everything you need to run. So with a standard PHP app, if we go really super simple and we're just using Apache and mod PHP, this will be a single image with all of our dependencies and all of our code inside of an image that we store somewhere. You can put it on Docker Hub, you can put it on Amazon, don't care where, but we'll have a pretty fat image with all of the data inside of it that we need to run our application. We can then pull that off the shelf and shove it wherever we ultimately need to deploy it. You should be able to run that build step multiple times and get the same output. If you're using your composer.lock file, you'll always get the same dependencies pulled down. If you're using the same image versions, they should all be pulled down the same every single way. When you're ready to deploy, you'll grab an image from the repository and shove it wherever it needs to go, be it my local machine, be it a QA server, like a QA cluster you've got set up, or an actual like Kubernetes production. But it's never going to actually build directly from the repository. You want to get in the habit of pulling those images from a registry, not building it and then deploying immediately. Tag all your builds, and by that I mean come up with a nice naming convention. I usually do it by date_version, because I might deploy like dev versions or QA versions multiple times throughout the day as we tweak little different things. But you want to be able to say, like, which version am I actually running in QA, in production? You know, query Kubernetes real quick and be like, okay, I know exactly what that is. And track all of your releases somehow. This is a little bit more important if you're doing like client or consultantware type of stuff. But if you have like a white box app product that you're selling off to people, tag who and what goes out to where. Different customers probably have different release schedules and are comfortable with different layers of work. But you want to know what actually goes out. And you want to know what version you're pulling down when you start to do development. If you are not building now, start small. Your build application can be run Composer, run npm, do whatever npm build stuff you need to do, and then use Docker build to just make an image. That can be your entire build step, and then shove it to a private registry. If you don't want to really worry about it, Docker Hub is super cheap. I'm not going to tell you how, but there are ways to get around some of their limits. But it's really super cheap and really easy to get into. I like pushing people that way because AWS can be very intimidating, especially if you're not deploying to AWS. If you're deploying to AWS, use AWS's registry. You're probably already fully invested in that stack. Just tack that on. For your build step, there's a couple of things you can look at. Generally, depending on how your application is structured, you might be using individual Docker files, or you might be using a multi-stage file. But I never keep my Docker file like in the root of my directory. I actually keep it in a separate Docker folder. So you can use -- file to actually point to a specific file separate from where you're running the command. I always recommend using --no -cache. Docker tries to be really super helpful in that if it doesn't need to rebuild an individual build step, it won't. But you really run the risk of getting outdated layers throughout there. If you've got something where you're pulling down a couple libraries for dependencies for different things, those can get out of date. And if those get out of date, you're not pulling in security fixes. That can be really bad from a lot of standpoints. So always get in the habit of not using a build cache for that. It'll take 40 seconds longer, but then you can fight on the chairs as you compile all your code. Good, a couple people laughed, so a couple people remember that comic. But mostly it's a security issue. Like, always make sure you're pulling down the latest dependencies that you have. And then do a dash dash pull that makes sure you're pulling the latest version of whatever your base image is, again, to make sure that you're getting all of the security updates and things like that. 3 or 4 years ago, there was a really bad outbreak where various versions of Bash had a lot of security flaws. Turns out a ton of containers should have updated, but they never did. So a ton of containers went out with a bunch of Bash flaws. You don't want to have that happen to you. So always do a pull to grab the latest version, and always use no cache to make sure you're getting the latest dependencies. So you can do docker build, dash dash no cache. In this case, we've got Docker in my Docker file is in a Docker PHP folder, because in this example, Nginx was in its own separate folder. Just makes keeping configuration files separate cleaner. So you'd use dash F to pass that into. And then dash T will give you your tag name. You really should be using like vendor / whatever, but I've only got so much screen space. And there's an option that most people don't really notice with Docker build, and that's that the last parameter for it, last argument, is actually where the root of your project exists. You don't have to run Docker build next to your Docker file. You don't have to run it anywhere near your code. You can point it to a file, and then wherever your build output is, and change the context where the Docker file runs. The Docker file will run in the context of whatever that last argument is. So you can have Docker build run from wherever and just point to wherever your build directory is. So a lot of times I'll actually have that build directory as like a variable in a shell script with whatever the last build folder is, because I'll randomize file names. And then the last thing you can do, or one of the steps in your Docker file you'll do, is you'll just do a copy. This is what trips a lot of people up trying to build these. Copy and add, if you want to use add, runs in the context of your build directory, not in the context of where your Docker file exists. So if I tell it to look in opt builds 2016-1010, copy will actually copy from that folder into my container from var www. If I run this command in the root of my directory, but I supply something, it's not going to run in the root of my directory. So that's where you can start to split things up. But you have to be really careful about the context this runs in. Because if your Docker file's in a subfolder and you don't change that target, it'll try to run in the context of that subfolder, not the root of your project. So that's something to kind of keep in mind. Another hot take of the day. Execute apps as one or more stateless processes. If you have more than one process in your container, you're doing it wrong. Don't at me, you're doing it wrong. Docker is not designed to run multiple processes in a single container. It can, but just because you can doesn't mean you should. If your container contains a supervisor process, like supervisor D, you're doing it wrong. Sorry, you're doing it wrong. If supervisor crashes, it takes everything else down with it. Because Docker will only ever watch one process at a time. It is not designed to run multiple processes inside of a single container. If you need that functionality, don't use Docker. Use something like LXC or LXD from Canonical. Those are designed to replicate an entire machine with a full init process and run multiple things at once. Docker only wants one process at a time. The reason for this goes back to my very first slide. If you're distributing your application across multiple servers, you don't need to scale everything all at once. So traditional PHP app, you probably have Nginx and PHP FPM at a bare minimum for your application. Those are two separate processes. Those are two separate containers. Don't use supervisor D to start up both of them. Because generally your bottleneck will not be both of them. If you're having slowness serving static files, then you will need to scale up your Nginx end, not your PHP end. If you need more raw processing power, scale up your PHP processes. This also allows you to swap out images as you need. So let's say you want to upgrade from 7.4 to 8. I don't think we're building 8 containers yet, but let's say when that day comes, you could just swap out that one image, not touch your web server image, and have a lot more fun with that. But make sure that you're not getting in that anti-pattern of running multiple processes in a single container. You want to get in the habit of, like I said, treating everything as an external resource, and if it has a network port, export that. You want your services to live on ports, not as sockets. This is built in automatically. Every container gets an IP address in Docker. So you can reference a container by its IP address and the port on it. This gets people a little bit confused because if they're running multiple Nginx, or let's say multiple PHP FPMs, those all are listening on port 9000. I now have a bunch of things listening on port 9000. That's awesome. But they're all probably running in their own IP space. And they all have their own individual IPs, so we can get away with that. Because we've properly separated everything out as external things, you're already talking over a network. Shouldn't be a ton of extra configuration from that end. This will also let you work with service locators that are port-based. There are some that will say, oh, this is port 80, we're going to assume that it's a web server. You will automatically dump this into a web server group. I don't personally like those, but there are some that makes life easier for people. Because we adhere to the one process per container rule, we can easily adhere to the concurrency rule, which is scale out via the process model. Scale out the things that need to scale. Don't scale everything 100%. You're just going to waste resources. You really have to think about what happens when your application scales, though. Docker will not make your application scalable. It will help you deploy multiple copies, but that doesn't mean your code's going to automatically know what to do. So your code probably runs perfectly fine right now with one single application. What happens when you have 2 of them running? What happens when you have 3 of them running? If a user uploads a file, how do the other 2 processes get it? Where are those things being stored? How are you handling that in your application? Docker's not going to fix that for you, but it allows you to scale out a little bit nicer. In the case of like uploading a file, you might want to consider doing something like fly system as an abstraction layer and saying, well, in development, we're going to do fly system to a local folder, but in production, it's going to be an S3 bucket. Because you're taking advantage of just changing that configuration at that specific deployment time. But again, we're doing one process per container, so we can scale those things just up. And you can scale up just a container that's needed. Docker Compose has ways to automatically scale your containers up and down in development. So if you want to test how your application scales, especially under load, you can say, give me 10 instances of PHP FPM, but 2 of Nginx. Does anything fall over as you start to run your tests? Ultimately, your app should not care how many instances of itself are running, just the fact that it is running. It should never know how many copies of PHP FPM are actually running, how many web server heads are in front of it. It just needs to know if I get a request in, how do I handle it? Docker won't tell your application how to do that, but it makes it much easier to test when you add that distribution in. I still haven't come up with a good phrase to replace the normal one, but your containers are cattle, not pets. You should be able to get them quickly and cull them quickly. And that's not the most vegetarian way of doing it. If someone else has a much better way of phrasing that, let me know. But generally, like if you're going to Google stuff, treat them as cattle, not as pets. They should start very quick, and they should gracefully shut down. I didn't say they should quickly shut down. They should gracefully shut down. Docker, because it starts a single instance, most of our applications start pretty instantly. Nginx and Apache have almost no boot time. Like they don't do a lot of logic to get set up. PHP just kind of starts and waits for a request. Databases sometimes take a little bit longer. But Docker will start a container pretty quickly. There's almost no difference between running a native process and running a container process. What you really want to start getting in the habit of handling, and this is more of a coding issue than a workflow issue, is how do things happen when they shut down? So what Docker will actually do is it will send a sig term to a container, not a kill term signal, so that your application can handle that. So you need to get, if you have like worker processes, think about how do they actually shut down. You might want to do something graceful like stop the current, like finish the current work unit and don't accept any more. Cal Evans has a really good book called Signaling PHP if you've never worked with POSIX signals before. It's like a $5 ebook. I would recommend picking that up just so you can get in the habit of working with those things. Because what will happen is Docker will send a sig term, and if it doesn't get a proper response or it's not timed properly, like you don't tell Docker to like wait longer, it will just send a sig kill and just kill your application right there. For most PHP applications, it's probably not a big deal. It really gets to when you're thinking about long-running processes and daemons, like if you're running React or workers or things like that. We kind of get this out of the box, dev and production parity. Use the same image from top to bottom. That's kind of the whole point of Docker, is being able to use that same image. But in your development process, use the exact same image that you build in production. When you pull it down to your machine, you can do things like host mount your volumes, so that way your code that you're live editing on your computer gets injected in, but you're still pulling down that same image you're using in production. Work with your team to make sure that your Docker Compose files, which should be in your repository and should be being version controlled, are being properly pulled down, and you're all using that same kind of static build. Yes, the production image is probably fairly large, but you shouldn't really probably be changing that terribly often. So we want to keep that as similar as possible. That cuts down on a lot of those problems. And then you're kind of left with just development issues where, like, I ran a composer update by example, for example, and that a new library has broken something, or like weird little machine-specific problems. Anything that you log, treat as an event stream. You never want to get in the habit of relying on local logs, because they will not exist in production. As soon as you remove a container, it gets pulled out of rotation. By default, the logs disappear. So on my machine, if I do a Docker RM, all those logs disappear. I have no way of getting any of those back. The nice thing is Docker has various logging methodologies built into it. The default is JSON, so if you do Docker logs, it's actually just reading a JSON file and spitting it out. Depending on what you're doing, that may work. You can tail it. You can, just like running the tail command to not see everything or to see it in live updates. But it's not really sustainable, especially if you've got multiple containers that you need to watch and you need to correlate events. So these should be all the main options that you can do out of the box with no special, like, additional plugins. What I would probably suggest, especially starting out, is using the FluentD. Unfortunately, there's no Logstash one, but FluentD is Logstash compliant, because then you can get in the habit of throwing those logs out to a third-party service, or at least another container to log those and get in the habit of it. Journald and syslog are really good, because if you have an ops team, they're probably already remotely shoving those logs away anyway, and they probably have a system for handling that. So don't go to FluentD if production's already using something else. Like, work within whatever your constraints are. One, you'll get the added benefit of everything is logged, but two, they're much more searchable. Because like I said, if a container dies and the system calls it, they're gone. You don't get those logs back. You also don't want to get in the habit of, like, what we used to do 20, 30 years ago, or last year, like for the most part for me, going onto a server and looking at the Apache logs. It's not sustainable. You won't have access to those clusters. Now, you can host this yourself, or you can pay for a SaaS if you're going to go and do this to push your logs. The Elk stack is one that many people are familiar with. You just can't use Logstash. You can replace it with FluentD. I'm going to assume most of you cannot read these examples. I'm going to read through them. I'll post these slides so you can get them later. But suffice to say, you're going to have a new section called logging in your compose file. You can tell it use FluentD and then basically point to whatever the localhost address that you're going to have. So in this case, I'm going to point it to localhost, and I'm going to give it a tag called apache.access. And then you can add a FluentD service to your Docker Compose file. So you can put this in like your dev config. But you can run FluentD inside Docker. There's no reason you can't do that. So you'll push your logs from one Docker container to another, and you really only have to pass in a config file and open up the ports. There is one thing you have to do. FluentD does not have an Elasticsearch plugin by default. You have to install it. So you'll probably have a Docker file for that, just to get that additional dependency. And we'll see. Of course, I closed that window. I'll change this so that it actually links to it. I didn't mean to close my Chrome window. But there's some config files you could set up in fluentd to push it off to Elasticsearch. And then you can run Elasticsearch in a container. So you can keep all of your Elasticsearch and Kibana, which is the visualization part. You can keep all the stuff in your Docker Compose file, scale them up when you need them, and shut them down when you don't. And then this can be part of a dev Docker Compose file, and you never have to have it pushed to production. Production can push to a fully backed up, compliant SaaS setup. If you've never used Kibana before, it has a nice web interface, horrible query structure. But so down here, below that little graph, you can see actually the actual log file that was dumped out. And you can search through this a lot nicer and correlate logs from multiple containers. Especially if you've got 5 or 6 FPM containers running, you don't know which container was actually talked to, so you can deal with that. Docker logs command, though, will stop working if you move it off the default JSON driver. So if you switch to using fluentd and you run Docker logs, you'll get no logs. I think unless you're paying for Docker Enterprise, but I honestly don't know anybody who pays for that. The example can be cleaned up a bit. There's some port things with that. So when you grab the slides, just keep note it's very much tailored for a slide format than like a true production format. And you want to get in the habit of containerizing all of the scripts that you need to run as commands. Docker will actually allow you to containerize your entire tooling structure as well as the actual applications that you're running. So in this case, we can have a test runner service. And if you specify a command, you can actually tell it to, by default, run a command. So I can do docker compose run test runner, and it will run my PHP unit tests for me. If I have database migrations that I need to run, especially in a production environment, you might containerize that. I hate having stuff installed on my laptop, especially multiple versions. Primarily, I'm a Linux developer. I do not understand how Homebrew works with multiple versions of PHP. So I will use Docker to have multiple versions of PHP installed. And I can swap those out based on the build parameter to different Docker files. And then run PHP unit under different versions of PHP. I can run all my NPM stuff under the various versions, because sometimes you get version locked. But you can start to take all of your commands, throw them in as services, and then you can Docker Compose run them, just like a regular command. Now your tooling actually moves from machine to machine and developer to developer, further reducing how much, further reducing the differences between each person's machine. Couple other tidbits while we got a couple minutes left. You can stack compose files to build up to a specific configuration. So Docker Compose allows you to specify multiple files with the -f flag. So you can have a base docker compose.yaml file, which just kind of skeletons out your services. And then you can have a production compose, which adds what your external ports are, what extra configuration variables you need, and then even a dev one, which might have different port bindings and does all your host mounting and things like that. So that way it makes it easier to deploy, and you can just stack those compose files on top of each other. So in this case, we might have a Docker Compose file, which by default says, hey, use the Nginx Docker file, open port 80 and 443. Here's our PHP stuff, and then MySQL. Really, you'll notice we're not pushing any code into here. If you were to live edit through PHP Storm or Visual Studio Code, the stuff you edit on your desktop is not going to be pushed into these containers. We're not doing any host mounting or anything like that. We can push that off to a dev file, which does add our volumes, which allow us to do our host mounting and stuff like that. So we can start to actually get that ability to say the configuration I'm using in production, I can also replicate down to my development in a true way, but also have an easy way to override for my development stack. One thing I'll do a lot is I will override the build to a debug build, which has xdebug and stuff like that. So I won't ship xdebug to production. I'll switch my Docker file to point to one that has xdebug installed, and I'll do that through my dev Docker Compose and set up all my xdebug stuff as separate environment variables. Then to use it, you just stack the -f. It does go left to right and override. So first it'll take Docker Compose, and then it will layer dev on top of it. One other kind of little gotcha is that for anything that's an array, like ports or volumes, it does not replace, it appends. So technically in this example, if I'm opening port 80 and 443 from my production one, those will also be open, and I don't open like port 8080 on here. If I had another port in here, we would actually have all three of them open, it won't replace. So that's one kind of weird thing to keep in mind. And then when you're doing a deployment, you just do like a Docker Compose up or whatever you're doing, use the production one, and it won't pull in all the debug stuff. Another cool thing you can do with Docker Compose is it will actually do variable substitution. So if you put any of your values in $ curly bracket, it will replace that from a local environment configuration. So you might do something like image is deploy version _PHP. It's whatever I last built. So then doing deployment, you can say deploy version equals 2018-05-25, Docker Compose up -d, and then it will actually inject that into that variable. This allows you to, especially during a build process, use a very generic compose file